Salam, peace be upon you. I am Muhammad Laik Siddiqui, the father of Holophase. Part 7. The knots in reality, where continuity learns to count. My friends, seekers, listeners, if you are with me now, perhaps while the morning light finds its way through your window, or as you move through the rhythms of your day, prepare to witness one of the most elegant secrets of existence. A secret hidden not in complexity, but in the simple, ancient act of returning home. We continue exactly where we left the infinite. In part 6, we plunged into the infinite zoom. We saw that reality has endless descriptive depth, an infinite language of derivatives, j infinity phi. But we, as finite beings, only read finite slices. We grasp the mantra, infinite depth, finite access. And we ended with a promise that from this smooth, continuous, flowing language of change, whole numbers can be born, integers can appear, discreteness can emerge from the seamless. How? How can the river of phi produce something as definite, as sharp as the number 1? The answer lies in an experience your body understood long before your mind learned to count. The experience of coming back. So, let us begin not with equations, but with your own physical memory. The tree and the turn. Close your eyes for a moment. In your mind, picture this. You're standing at the base of a great ancient tree. An oak, a cedar, a baobab, something with presence. You place your hand upon its bark. You feel the texture, the life beneath. Now you begin to walk, slowly, deliberately. You keep your hand on the rough bark as you walk a full circle around the tree's massive trunk. Your feet trace a perfect loop in the earth. You pass the point where you began, and finally, you arrive back. Your hand touches the same spot of bark. Question: how many times did you walk around the tree? The answer is not approximately 1. It is not 0.99 or 1.01. It is 1. Precisely. Definitely. One whole loop. Why? Not because you counted your steps, but because the condition of returning to the same place defines the wholeness of the loop. The same place is a specific singular state. To leave it and come back to it completes a cycle. You cannot come back to exactly the same place having completed 9/10 of a loop. That would be a different place. The wholeness of the number is forced by the journey itself, by the topology of coming home. Now, feel this truth in your bones. This is not just about trees. Phi is cyclic. Remember, phi is not a number on a line. It is a potential for connection that lives on a circle. Its values are like points on a compass, or phases of the moon. 0 radians and 2 pi radians, 360 degrees, represent the same comparable state. They are identified. They are home. So what happens when we track the change of phi, our d phi, not over a tiny step, but over a journey that returns to the same starting comparability? We must perform a special kind of sum. In mathematics, it is called a closed-loop integral. We write it with a circle on the integral sign, d phi. It means take the total accumulated change of phi as you travel along any closed loop in reality, in space, in time, in any configuration space, and return to your starting condition. And here is the beautiful, inevitable, crystalline result. d phi equals 2 pi n. In audio, the closed-loop integral of d phi equals 2 pi times n, where n is not a fuzzy number, not a fraction. It is -3, -2, -1, 0, 1, 2, 3. An integer, a whole number. Let's say it plainly. The total phase accumulated around any closed loop in reality is quantized. It must be a whole number multiple of 2 pi. Why? For the same reason, walking around the tree yields one loop. If you start at a certain phase and you return to that same phase, the total change must be exactly an integer number of full cycles. You cannot come back to the same phase having shifted by, say, 1.5 full cycles. That would land you at the opposite point on the circle, a maximally different phase. Sameness demands integer winding. Discreteness, digitalness, is not imposed on nature in this view. It is forced. It emerges inevitably from the logic of cyclic comparison, from the topology of coming home. This is the monumental pivot of part 7. We did not assume the universe is digital. We did not start with particles and quanta. We started with a single, continuous, cyclic primitive, phi, and the act of comparison. We followed the logic of measurement, change and return. And integer numbers fell out of the mathematics like ripe fruit from a tree. They are the knots in the fabric of reality, the circle you carry inside you. Now, let's deepen the intuition. Why 2 pi? Because 2 pi is the length of one full turn on a circle when you measure in radians. You've met this without realizing. A circle's circumference is 2 pi times the radius. 2 pi is simply all the way around. So when we say the total change equals 2 pi times n, we're saying the total must be an integer number of full turns. One full turn is 2 pi. 2 full turns is 4 pi. 3 full turns is 6 pi. The miracle is not the number. The miracle is that return forces the number to be an integer multiple, even though every tiny step along the path can be continuous and smooth. Think of a clock. The hand goes around. It can go half a turn, 3/4 of a turn. But if you say the hand returned to 12, you have said something exact. It has advanced by a whole number of cycles. Not a half cycle, not 0.83 cycles, a whole number. That is how a circle works. And Holophase says, phi lives on a circle like that. The knot. When return fades locally, but survives globally. Now comes the deeper shock. Sometimes you try to make the phi field smooth everywhere, to iron out all wrinkles, to make it calm and consistent. But you cannot, because the circle allows winding, and winding cannot always be removed by local smoothing. This is the meaning of a topological defect. A defect is not a tear in a fabric made of stuff. A defect is an obstruction in the language of comparison. Locally, the field may look perfectly smooth, but globally, when you go around the loop, the field insists, I have wrapped. That wrap is not a continuous variable. It is an integer. That integer is the defect's identity. So a defect is a knot in reality's fabric, not a knot in cloth, but a knot in the comparability structure of phi. A simple picture. The rubber band and the pole. Imagine a rubber band around the pole. If the rubber band goes around once, you can feel it. If it goes around twice, you can feel it more. You can stretch the band, you can wiggle it, you can slide it up and down. But you cannot remove the wrap without lifting the band over the top or cutting it. That is topological stability. The number of wraps is preserved under smooth deformation. It can only change through a discontinuous event, lifting it off or cutting. Holophase says a phi winding is like that. As long as your licensed window preserves coherence and continuity, the winding number n cannot change smoothly. It is stable, it is protected. That is why these integers behave like particles. They are stable not because they are made of hard substance, but because you cannot unwind an integer without doing something discontinuous. Particles as knots, the deep reframe. Now we say the line that transforms how you imagine matter. Particles aren't little balls. They are knots where difference wraps around itself. In a phi-based universe, a particle-like object is a stable topological feature, a place where the field cannot be globally smooth without changing the winding class. The stability is not because the particle is a tiny rock. The stability is because the integer cannot be continuously erased. So when you see a countable object, you are seeing topology made visible. You are seeing the universe's grammar hold. This is a vision of breathtaking unity. Matter, force, and number are woven from the same thread. Matter is knots with winding, like electrons and quarks. Force carriers are waves or disturbances in the knotted background, like photons. Numbers are the winding counts of the knots. All arise from one primitive, cyclic, comparable phi. Why is electric charge quantized? Let's make this stunningly concrete. In our world, every electron has exactly the same charge, minus 1.602 times 10 to the minus 19 coulombs. Every proton has exactly the opposite charge, not approximately, exactly. Quarks have charges in neat thirds. Why? Why not a continuous spectrum of possible charges? The standard model of particle physics inputs this fact. It puts quantization in by hand. But in Holophase, we do not input it. We derive its possibility from first principles. If the electromagnetic potential is related to a cyclic phi field, and if isolated, stable particles correspond to topological knots in that field, then the charge of that particle is proportional to its winding number, n. And since n is an integer, charge is quantized. It comes in whole number multiples of a fundamental unit. The electron is not a tiny hard ball of charged stuff. It is a stable topological knot in the fabric of the electromagnetic phase field. A knot with winding number -1. The proton is a more complex composite knot, but its charge is +1, a whole number. This is not yet a full derivation of the standard model. That is work for decades. This is the compelling logic. The beautiful logic that says, if your fundamental field is cyclic and particles are topological defects, then quantization is not an add-on. It is a geometric necessity. And it extends beyond charge. Quantum mechanical spin comes in half-integer multiples of h. This too is quantization. In the topological view, spin can be related to internal winding in abstract spaces. The wholeness, the discreteness, has the same origin. The topology of cycles, the very existence of stable particles. Why is matter grainy? Why can't we have half an electron? Because an electron is a knot. You can have one knot, two knots. You cannot have half a stable, fundamental knot. Stability and countability are two sides of the same topological coin. The prediction of part 7. Now we stamp part 7 with its clear, testable prediction. Prediction. Any stable, particle-like entity in a coherent physical theory must exhibit integer-valued topological invariants, quantum numbers. Its charge, its spin, its baryon number. Any property that signifies a knottedness in an underlying cyclic field must come in discrete, whole number, or half-integer steps. The stability of the particle is directly tied to the topological protection of this winding number. In simpler audio language, what we call a fundamental particle is a knot, and knots are counted with whole numbers. The falsification of part 7, and this gives us our clean, sharp falsification. Find a truly fundamental, stable, particle-like entity whose primary identifying properties, like charge, are continuously variable. Not just measured imprecisely, but fundamentally, in principle, able to take on any value on a continuum. A stable, coherent defect with a fractional winding number, say n equals 0.7, that persists under license conditions. According to this framework, such an entity should not exist. Its discovery would break the topological emergence of discreteness. So far, every fundamental property we have discovered in nature is quantized. Charge, spin, color charge. The universe appears to be made of these topological knots. The firewall in practice, licensing the loop. Now, let's get practical. Holophase is not poetry, it is a disciplined method. How do we actually claim an integer winding? We need a licensed loop. A loop defined within a window where coherence is high enough that phi differences can be tracked reliably. If coherence collapses, the loop becomes fog. The integer becomes unclaimable, not because it ceased to exist, but because your access broke. This is why Holophase says, quantization is not a metaphysical superstition. It is a measurement fact that depends on licensing. In a clear window, the integer stands like a rock. In a foggy window, you see only blur and noise. So the operational protocol is define your loop within a licensed window. Specify time, space, coherence threshold. Measure d phi along the loop with uncertainty estimates. Sum the changes, integrate. Divide by 2 pi. See which integer n the result is closest to within your declared uncertainty. If the uncertainty is small enough that n is unambiguous, the count is licensed. If not, you cannot claim the integer. This is how we turn topology into a countable measurement, not metaphor. The two infinities revisited. Recall from part 6. We must distinguish two kinds of infinity. The universe's descriptive infinity. The fact that patterns can be differentiated forever, the infinite zoom. This infinity is earned through measurement. The mind's creative infinity. Our human capacity to invent explanations forever. This infinity is free, untethered. The purpose of the licensed loop, the coherence requirement, the uncertainty accounting, all of it is to prevent the second infinity from impersonating the first. We are not imagining knots. We are measuring winding numbers under strict conditions. The dangers on the path. On this journey, there are two cliffs to avoid. Depth denial. The stance that says, if I can't see it with my current window, it isn't real. This confuses our current sentence with the whole language. It is the voice that says, atoms are a fantasy. Depth addiction. The intoxication that says, I will always go deeper, even into the fog, and tell stories about what's there. This confuses the mind's infinite creativity with the universe's depth. It builds castles of theory on foundations of noise. Holophase is the narrow, disciplined bridge between these cliffs. It celebrates infinite deepening, but demands each step be purchased with coherence, calibration, and the ever-present possibility of being wrong. Why continuous and discrete are not enemies? A crucial point often misunderstood. Holophase is not saying the universe is a pixel grid. We are not saying space is made of squares or time ticks digitally. We are saying something more subtle and powerful. When the primitive is cyclic, global closure produces integer invariants. Those integers can behave like discrete objects, while the underlying field remains perfectly continuous. A smooth rope can carry a knot. A continuous field can carry an integer winding. Discreteness here is not pixels, it is global class. You can have perfectly continuous local behavior and still have discrete global identity. This is the profound synthesis: continuity and discreteness as partners, not opponents. A story of the river crossing. Why internal identity feels like thingness. Imagine watching a caravan cross a river. People come and go, camels move, dust changes, sound changes, but you can still count. One caravan arrived, 2 wagons crossed, 3 riders remained. The count gives identity in a world of flow. Topology does the same in physics. The field may fluctuate, local details may change, but the integer gives a stable identity you can track through time. This is why the universe's knots feel like objects. They are trackable, conserved like entities in a world that is otherwise a sea of change. Objecthood is bookkeeping made physical. How this changes how we see. Let's connect this back to your daily experience. You are not a collection of tiny billiard balls. You are a vast, dynamic constellation of topological knots, knots upon knots, tied in hierarchical structures, vibrating within and shaping a seamless, continuous field of potential. Your stability, your solidity, comes not from solid stuff, but from the persistence of pattern. The knotted patterns are protected by topology. They cannot easily come undone. That is why you persist through time. Love and connection. When two people feel a deep bond, could it be understood as a kind of topological linking? Two complex knots becoming entwined, their windings affecting one another, creating a new joint invariant. The bond has a strength, a persistence that can feel quantized. I love you completely, not I love you 0.8 units. Ethics and value. If persons are topological patterns of supreme complexity and stability, then causing harm is not just interfering with matter. It is attempting to untie or mutilate a knot of immense, intricate value. The sanctity of life finds a new language, the preservation of coherent topological complexity. The handoff to part 8, from knots to force. Now, a final mystery arises, leading us to our next step. If an electron is a knot and another electron is another knot, why do they repel? What is the push between topological defects? The answer lies in the interaction of their shadows, the omega, kappa, and nu fields that emanate from each knot. The knots distort the smooth phi field around them. When two knots come close, their distortions interact. This interaction can be calculated from the triunity equations. In the simplest topological field theories, the interaction energy between two knots with winding numbers n1 and n2 is proportional to n1 times n2 divided by the distance between them. Does that look familiar? It should. It is the structure of Coulomb's law for electric charges. The force between 2 point charges is proportional to the product of the charges divided by the distance squared, the product of the winding numbers, n1 times n2. This is not a coincidence. It is a glimpse of the Holy Grail, force as geometry. The repulsion between two electrons is not a mysterious action at a distance. It is the geometric and topological interaction between their phase field distortions. Their charges are their winding numbers. The force law emerges from the mathematics of the field, trying to minimize its total energy given these topological constraints. This will be the subject of part 8, the geometry of force. where we see how the push and pull of the universe, electromagnetism, gravity, the nuclear forces, are not primary ingredients but secondary consequences. The dance of shadows between knots. But before we go there, let the revelation of part 7 settle into you. What you carry from part 7. Let me compress the heartbeat of this part for you to carry. Reality has infinite descriptive depth, but finite access. When that reality is cyclic, and you go around a licensed loop and return, the total change must be a whole number of cycles. That whole number is a topological invariant, a knot. These knots are stable, countable, and we identify them as particles. Their integer nature explains quantization, charge, spin, and the very grain of matter. Your mantra. Whole numbers come from going around. And the deeper version, particles aren't little balls, they are knots where difference wraps around itself. This is not a floating metaphor. It is an operational claim tied to the loop integral, to coherence licensing, to prediction, and to falsification. After practice, feel the knot. Here is a practice you can do today. Take a string, a cord, a scarf. Wrap it once around your finger. Count. 1 wrap. Wrap it twice. Count. 2 wraps. Now, try to smooth 2 wraps into 1 wrap without removing the string. You can loosen it. You can slide it. You can deform it. But you cannot continuously turn 2 wraps into 1 wrap without a discontinuity. Taking it off, cutting it, or passing an end through. That is topology. That is protection. That is part 7 in your hands. You are feeling the persistence of an integer. The universe as a path that must close. Imagine the universe hands you a path and says, walk it, return, tell me what you learned. You walk, you measure differences, you add them, you return. And the universe says, now do not tell me a story, tell me the count. That is topology. That is the knot. That is the birth of integers from continuity. We began with a simple, almost naive principle that all of reality stems from the potential for connection, phi. We followed its logic with rigorous discipline, through measurement, d phi, through its threefold appearance, triunity, through its infinite depth, infinite zoom. And now we have reached the pinnacle. This smooth, continuous starting point has spontaneously generated discreteness. It has given birth to number and particle. We did not put the numbers in. We found them. They were hiding in the act of coming home. So, as you go about your day, practice seeing the world this way. When you turn a key in a lock, feel the single definite turn, a whole cycle. When you walk from your front door and return, acknowledge the completed loop, a topological event in your life. When you look at your own hand, remember, it is a temporary coherence of countless knots, a finite reading of infinite, knotted potential. You are living in a universe that counts, because it is a universe that returns to itself. A universe that knows what it means to be the same. A universe woven through with the silent, steadfast integers, the eternal knots in the flowing cloth of connection. Until we meet again for part 8, peace be upon you. And know that with every complete circuit you make, you are echoing the primal topological logic of creation itself.